Alright, so in this tutorial we are going to learn how do you divide a given line into a required ratio, okay? In this case, take a look at this diagram. We have this line segment AB and we don't know what the total length of this line is, but we want to divide this line. Let's say divide in the ratio, and that ratio is 2:3, okay? Now there are a couple of ways to divide this line into the required ratio, okay? One could be that you could simply take a ruler, measure the total length, and then divide that total length into the required ratio by dividing into those parts. Sometimes we do that, right? But sometimes, for whatever reason, that technique may not work, then we should always be prepared for learning alternate methods of how do you divide any line segment into a required ratio, okay? Especially when the line is not parallel to either the horizontal axis or the vertical axis. And this one is exactly one of those, that it is inclined at some angle with reference to the horizontal axis, okay? So what we are going to do is that we are going to complete a triangle, and we can do it by dropping a perpendicular from the point A, and then wherever that perpendicular is intersecting with the base, let's say this base is B and C, okay? So this completes a triangle ABC, right? And this is my right angle triangle, okay? Now take a look at these numbers. This ratio A:B, right? What we do is we simply sum up these two numbers. A:B is 2:3, and 2 and 3, that will make a total of 5 units, right? So whatever is the length of this base BC that we have obtained, we are going to use this to divide this line segment AB. How? Let's take a look at that. What if I could divide the base into 5 total parts, right? Whatever is the length, I want to divide this base into 5 total parts, and I can do it very easily using the coordinate geometry that I already have these divisions on the horizontal axis, right? So there are 5 total divisions, okay? And then I count that how many of those divisions will be equal to 2 units, and then from there the remainder part of this base BC will be 3 units. That means as our step 1, you have used this ratio to divide this line segment BC into the part 2:3. And let's say that E is that point which divides the base BC into 2:3, okay? Now what we will do is that from this point E, we will simply create a perpendicular such that it intersects with the line segment AB, okay? And that intersection will happen at point D in this case, okay? So what you have obtained so far is that you have obtained a line which is DE, and that line is parallel to the line segment AC, right? This line segment we are talking about, correct? Now you have obtained your required ratio because AD will be 2 parts and DB will be 3 parts. And this is exactly what you wanted, that the line segment AB, it has been divided into 2 parts. One part is AD and the second part is DB, and the ratio of this is 2:3. Now you'll be wondering that how do you ensure that this is indeed the ratio 2:3? And that certainly we could prove using our discussion or knowledge that we gained from our learning on triangles, okay? So if I have a triangle, let's say this is my triangle PQR, okay? And if I create a line, another line which is parallel to the base, let's say the base is QR in this case, okay? And this line which is parallel to the base intersects with the remaining 2 sides of this triangle PQR such that it intersects at the point A and point B. Then we remember that such a line segment AB can divide the remaining 2 sides into certain ratio, and those ratios are always equal to each other, meaning the ratio of the line segment PA to AQ will be equal to the ratio of line segment PB to BR. This is what we learned and we remember from our discussion when we were learning about triangles, okay? And that is precisely what you have done here, that you have a line segment DE which is exactly parallel to the line segment AC. If that is the case, the line segment DE is going to divide this line segment AB and CB such that the ratio of their division is always going to be equal. That means the ratio of CE to EB will be equal to the ratio of AD to DB, and that is what we had, that this ratio is 2:3. And that is exactly what we wanted. So you see that all the things in coordinate geometry are connected with each other, and that's exactly what we wanted to learn in this one small example, that how do you divide any given line, no matter what the angle of that line is with reference to the base, how you can use the principles of coordinate geometry to divide any line segment into your required ratio. And that is what we wanted to discuss in this tutorial. In our next tutorial, we will discuss that how we can use the principles of coordinate geometry into determining the area and perimeter of polygons or any shapes in 2 dimensions.